Hi, this is the second video in the playlist where we're looking at the total surface area of cylinders. Please do stop the video, have a go at the question and then compare your solution. Particularly the second one, which is a little bit more challenging. Hope it's useful to you. Please add a comment below if you're not sure about anything. I'll come back to you and I look forward to seeing you inside the video. Hi, this is the second video in the playlist where we're looking at the total surface area of cylinders. Please do stop the video, have a go at the question and then compare your solution. Now, number 3 here is a little bit trickier because it's a solid semi-cylinder. In other words, it's been cut in half from a full cylinder. So just got to be a little bit careful. But what I'm going to do is I'm actually going to use the same technique as I did in the first video, and that is write these things out as a net first. Okay, so here we've got A, which is this semicircular shape. Okay, and then I've got underneath is going to be a curved rectangle. So I'll call this B if you like. So a curved rectangle, and that's going to go underneath. Okay, and I'm going to write in there just because I think it's important to show the examiner what it is you're doing, and also just to kind of keep yourself focused on what we're looking for each time. So it's a curved rectangle, okay, which is the bottom piece. And then we've got the other side, which is another semicircle. So semicircle at the other side, okay. And then lastly, we've got the rectangle at the very top here. Okay, so this is going to be a rectangle at the very top of this particular shape. Okay, so hopefully that breaks it down okay for you. So it is a case now of putting in the formula and some numbers to kind of make it work. And I have given us quite a lot of information, so we should be okay with it. Okay, now you'll recall that the area of a circle is pi r squared, but this is only half a circle. So I'm going to say it's a half of pi r squared. Okay, so let's put a number in there. I'm going to get a half times pi, and the radius, now remember they've given us the diameter here, so the radius itself is going to be half. So if you like, the radius is going to be 5 millimeters, so that's going to be 5 squared. Okay, now if I work that out, put it in a calculator, however you want to work it out, you're going to get 12.5 pi. Okay, now I know it's going to be the third one, exactly the same answer for that. So I'm going to write that in now. So it's a half pi r squared equals a half times pi times 5 squared, which is 12.5 pi. And it is worthwhile doing this because sometimes I see with students you get a lot of calculations, you know, all over the paper, but if you're a little bit structured in the way that you answer it, then you'll pick up marks, but hopefully also you might minimize any errors that you might make. Okay, so let's have a look at the curved rectangle. Now, again, you recall that if it was a full circle, then the perimeter of the circle is pi d. Well, we've only got a half of it, so this length along here, which is going to be this length along here, is going to be a half of pi d. Okay, hopefully that's all right for you. Okay, so the height, which is going to be this one along here, or this one along here, is going to be 62. Okay, so it is a case now of putting those numbers into the formula, and let's see if we can come up with a number for the area of the curved rectangle. Okay, well, it's going to be a half times pi, and the diameter is 10. Okay, multiplied by 62. Okay, so a half of pi times 10, that's going to be 5 pi. And 5 pi times 62 is going to give us a total of 310 pi. Okay, so now we've got the semicircle, the curved rectangle, and the semicircle at the other end. And the final one is the actual top of the shape, which is this one here. Now the top of the shape is going to have a length of 62 and it's going to have a height of 10. So it's this one along here by 62 along here. Okay, well 62 times 10 is going to be 620. Okay, so the total surface area then is those numbers all added up together. So I've got the total surface area is going to equal 12.5 pi. I'm going to write it as a column. 310 pi. Now remember, I've got to keep the decimal point in the correct place. 12.5 pi. Okay, and then I'm going to add it just to a plain 620. Okay, so just be very careful. This is the top rectangle, which doesn't have anything to do with pi. Now, I put that into a calculator. I'm going to get 1672.4335 millimeters squared. Okay, it's asked us to give the answer correct to 2 decimal places. So the second decimal place is 3. So my answer is going to be 1672.4, and 3 is going to stay the same because the number after it is also a 3, and this is 2 dp. Okay, hopefully that's okay for you and you're able to work through that particular question. But as I mentioned, try to do these things as methodically as possible. Okay, so let's have a look then finally at question number 4. Now this is slightly trickier, slightly more difficult, and you're going to need some algebraic ability with these sorts of questions because they've not told us the radius. What they've said is the total surface area is 216 pi. Now that's made up of, as we've done before, our net. Okay, and the top is going to be pi r squared. The bottom is going to be pi r squared, and they're both going to be exactly the same radius, which is x. Okay, the rectangle which goes around is going to be pi times d. So this is the circumference of the circle multiplied by 12. Okay, so let's see where that takes us. Now, it's going to take a little bit of time to kind of work out. Okay, so let's have a look here. So we've got pi times r squared. Well, we don't know r, but we could write this as pi times x squared. Okay, and it's exactly the same with the bottom one, pi times x squared. Okay, so if I add those two together, which I'm going to in a minute, I'm going to get 2 pi x squared. Let's have a look at this one now. You'll recall the diameter is going to be 2 lots of the radius. Okay, this is actually 2 times x. So I've got 2x pi multiplied by 12. Well, that's going to give me 24 pi x. Okay, hopefully that's okay for you. Hopefully you're able to follow that. I've got 2x times pi. 2x times pi. Remember, it doesn't matter which way around I write them. It's just neater to do it like that. And then multiplied by 12. So 12 times 2 is 24. And I've got x pi, 24 x pi. Okay, so what does that mean? Well, if I add all of these numbers together, I'm going to get 216 pi meters cubed. Okay, so let's have a look at this. So the total surface area is the sum of these 3 numbers. So I'm going to get 216 pi equals... And remember I said pi x squared plus pi x squared is going to be 2 pi x squared. So 2 lots of pi x squared plus the bit in the middle, 24 pi x. Okay, now that seems a little bit scary canary to start with, but it's actually not too bad once we kind of work through. I'm just going to move my paper up a little bit so you've got the full paper. Okay, so the first thing I'm going to do is I'm going to bring this 216 pi over towards the right-hand side. Now, the reason I'm going to do that is because I know I'm going to have to factorize this. I've got x squared. It's a quadratic that I'm going to have to factorize. Okay, so if I do that, I'm going to get 0 equals 2 pi x squared plus 24 pi x plus, minus 216 pi. Okay, now the next thing I'm going to do is get rid of the pi. I don't really need it. I can just divide through both sides by pi. 0 divided by pi is still 0. Get rid of that one, and that one, and I'm going to get 2x squared plus 24x minus 216. Okay. All right, so next stage then is to get rid of the 2's or divide through by 2, because if I do that, it just makes my number a little bit simpler to deal with. I'm going to get x squared plus 12x minus 108. And then really it's a case of factorising this. Now you might recognise that you've got minus 108, and what I'm looking for is two numbers that when I multiply them together make minus 108, and when I add them together make plus 12. Okay, now it is a little bit tricky, this particular one, but you might hopefully be able to work that through to get this to be plus 18 and minus 6, because 18 times minus 6 is minus 108, and 18 plus minus 6 is going to be plus 12. It's the same as saying 18 minus 6 will give you plus 12. So actually I can write this now as x plus 18 multiplied by x minus 6, and that equals 0. So now I've got my two values of x. Okay, one of them is where x plus 18 equals 0. So therefore x equals minus 18. And one where x minus 6 equals 0, so therefore x equals 6. And actually that's my answer. The value of the radius is going to be 6 meters. Okay, and that would be the answer. Now the reason it's not minus 18 is because that doesn't exist. You can't have minus 18 meters as the radius. It's only going to be the positive value. Okay, so that's quite a long way into this video. I hope you've been able to stick with it. If you're not sure about this question, please do add a comment below. I'll always come back to you, and I look forward to seeing you inside the next video.